Hi there. Time to continue our project. Um, so the last time we created different parts of a command list and command queue manager set, as well as resource state managers. Um, and we actually did link all of these components uh, and did some lifetime object handling. Of object lifetime handling, of course. Um, yeah. Um, so I've decided to change the roadmap a bit. Um, as mentioned in the previous episode, I wanted to move some parts of the logic, since they kind of resemble something which could be considered parts of a draw method. Um, and I've decided that depth stencil and viewport stuff will be implemented later when we actually have something to show to our screen. The depth stencil is responsible for handling uh, the depth of view, meaning that it will uh, call pixels that aren't supposed to be shown. And the viewport is just a way to slice a render target. You can use several viewports for rendering different render targets and thereby combining different render passes in one image. Yeah, so we will save that for later and implement them somewhere around when we actually do draw calls. First, we will do the update draw method, the resource slash buffers, and a linear buffer uploader. It's basically a a a buffer that uh, automatically copies whatever content of the input buffer to a destination. Uh, and it will take raw data, which means that we don't need an intermediary for different objects. First, I'll start out with the update draw methods. If we are to update our diagram, we want to be passing some data into our pipeline. Let's see what's a suitable color for data. I guess that one is pretty fat. There we go. Um, of course, the commands will always reference the data in some way or form. Perhaps they are already uploaded to our shaders uh, by using the commands, or yeah, previous commands, of course. So let's get going. So if we ever get to the end of the init function, we should of course return true. I would like the renderer to have a this is an initialization call, a somewhat destruction call, but yeah, it's not really only a destructor only call. It just allows us to flush the swap chain if we need to resize or something like that. Therefore, I won't position it where I usually position function methods that handle object destruction. But yeah, we would like a void draw, or rather render method. Inside that, we would like to begin a frame, and we would like to end a frame. This is fairly typical in terms of render logic. So usually render will call begin frame, end frame, and then present. This is the usual logic. So we set up our swap chain. We start transitioning the back buffer, which is actually a part of every frame. We want to be able to render to the back buffer. Therefore, we move it into our begin frame. Since it's quite unreadable, I will structure it like that. As part of a begin frame call, we would like to clear our back buffer, and we would like to when we're done with a frame, we want to make it ready to do the swap chain present call. Let's reorganize this as well. There we go. Whoops. There we go. And we actually want to make these calls after we have presented this was just in place in case we needed to wait before everything got destroyed. I'm not entirely sure that we actually need it because we've implemented a likewise method here, and when we flush, we create new fences that we have to wait for during the release method. Therefore, object lifetimes should be fairly yeah, safe. All right. Afterwards, we call the reset commands. And that should actually be it. So this is a frame, or at least I think so, if everything works. We do the render call. And if our application let's see, preferably we would like to make sure that the renderer is actually initialized before we do anything. We have this run loop which we could make run our update method on update and on draw. So one is for simulation, one is for drawing whatever needs to be drawn. Yeah, so let's do on update while we run, which is, if you forgot, the main thing we do while running, and on draw. And let's see. Yeah, usually I don't like branches, but we can't avoid them always. Let's see. Maybe the renderer needs a flag. Yeah, we can't avoid branches entirely, and at least we're not processing any heavy data, so if the renderer, let's see, we have to initialize it as false when we're done. Uh, if we get this far, we will always have enabled it. I'm unsure where the branch is supposed to be. I'd prefer if this part of the code was somewhat branchless. Yeah, maybe we want it during the draw call, because we will be calling the render function. Yeah, maybe. Let's do an inline function that returns a bool. And we will return the flag. Yeah, I'm not crazy about doing a branch, but otherwise I could, if I was supposed to make it somewhat branchless, I could, well, I'd have to put it in a branch somewhere else, but yeah. So if it was in the message processing, or even before that, so is running is going to be true, and thereby we can start running, processing the message, which creates the window and actually calls the onCreate, which calls the initialization of the render, which has to follow. Yeah, somewhere there has to be a branch, I think. Otherwise, it would have to be inside the actual objects, and I don't like doing too much branching inside the objects themselves. Um, I mean, if a swap chain isn't initialized and has to check whether its internal state is correct and everything is up and running, yeah, I think it would get somewhat slow. Why even do a draw call, which is a more expensive call in the first place if we do not have the required state? I think that on a higher level, branching is better, since we would be end up doing all this stuff uh, just to not do a present. And what if we try to do one of these calls before? I mean, we actually enable and initialize the command list managers, and yeah, because we fetched yeah, we could do it on object creation, but we still need the actual handle. I think it's fine. If you have any suggestions or objections to this, please let me know. Yeah. So right now we do the update. It's gonna be a separate section where we do simulation calculations in the future, and then we draw everything. Um, the renderer will handle if our data needs to be interpolated between points and everything. So, um, or maybe we just pass in already interpolated data during, or rather from the update method. Um, yeah, but we will get there eventually. All right. So everything got moved out of the initialization method and into a renderer method. Um, and I think everything should be fine. We should see a black screen. Yeah, and that we do. We do have, as you can see in our output, a sort of uh, uh, range of errors. It seems like I've forgotten to open the graphics command list after closing it. This should of course be part of our um, part of our reset commands. Let's see, I think I did an inline method on the header file. Yeah, so if we want a graphics command list, we can always call the graphics command list to get that reset. I think that opens it. Yeah, let's see. Let's look it up. So graphics commands list. Oh my god, death by tabs of your browser. I'm not using much any of these, but yeah, I usually just open a new tab whenever I want to look something up. If I get curious about something, and then I usually forget to close the tabs. And every time I want to look something up, I never check whether I have a tab open that actually is usable for that exact thing. Oh well. So yeah, so we need to call a reset on our command list allocator. Yeah, I think I would do this branchless again. So branches are, let's see, it actually takes in an argument. All right, so we're gonna um, move that branch, move that bus. Did anyone ever see that program? Move that bus. And as before, our initial state, pipeline state, is currently 0. So we will just pass in a pointer to our command list allocator. And then a 0. And since we're inside a static method, yeah, we kind of did that. Huh? Let's see. Yeah, it was just IntelliSense messing with me. At least IntelliSense stopped messing with me after I ported the whole project. I had some trouble. Yeah, okay. It's somewhat sluggish here. I think that we might be uh, doing something slightly wrong. Um, yeah. Uh, let's see. Maybe it's because we actually need to reset the command list allocator. Also, no, we get an error if we do that. So let's see what to use after close. Uh, Maybe it's because we get out of sync, so we kind of just like load the GPU with endless endless commands to clear the render target view, and um, yeah, maybe we should do some waiting after all. So if we allow it to do exactly one frame in flight, uh, yeah, so we have to write it out. So before we reset the commands, we would like to wait. So we ask our um, command queue manager, could we get a fence? And what is the completed value of that fence? While that is lower than our command queue's current fence value, we wait. And as before, I would like to know every time we wait, at least for now. And let's see, let's do the intrinsic for pausing. Yeah, now it's not sluggish, and it's not spamming errors here. So that was the problem. We were overloading our GPU with uh, frames which had nothing. We do see though that we have some kind of memory leak. Let's see. That is not great. Let's see. Does it bug out if we what is actually creating that memory leak? Let's see. So we must be allocating something. Let me just see if I end up recreating a command queue and or created command queue manager, and let's do the same here because I'm unsure whether that is the actual memory leak. We're not supposed to have a memory leak. Nope, that's not it. It only happens once. Great. We can actually leave that in. It doesn't matter. It doesn't matter. To quote The Rock. Maybe we just want to do... Is it the intrinsic? Nope, it's not the intrinsic. What on earth is happening? So, our application runs the on update. Let's see, where did we go? We have a memory leak somewhere. Let's see what happens if we actually close the application. That's fine. That ain't pretty. So if we disable the render call, we will know if the memory leak is happening inside that. Alright, it is. So somewhere in the renderer call, let's see, if we disable this part, we're memory leaking, and very, very fast. Alright. Let's see. If we don't clear the render target view, do we memory leak? Yeah, we still do. Let's see. Do we... This should be static. So if we... So if we just spam... Yeah. We can't do that. We can't do that, obviously. So if we... let's see. Let's disable the resource transitioning for now. Yeah. It's somewhere inside the resource state manager, or yeah. Let's see if we call that over and over and over. Do we get a memory leak there? Nope. Nope. Maybe. Maybe. Let's see. Maybe we actually create a buffer. Oh, it is a pointer though. Let's see. Nope. Get current buffer. Is it because it's... Peculiar. Let's see, we pass in a pointer sub resource. Let's see if we just nope. Let's see. Now that doesn't memory leak anymore. Why? Because no, that is still running. If we do that, everything gets out of hand. So if we do not record that, command, we do still have a memory leak. What if we don't present? Wow. Let me see. That is somewhat weird. So yeah, it's somewhat... Yeah, we don't process messages when I drag the window around. Memory usage. Huh. For some reason, it fails. Let me see what do I usually do. Uh, let's see. Uh, uh, it's a graphics command list. Um, let's see. Uh, we execute the command list, which has one. We increase the fence. That is really, really, really weird. That is really, really, really weird. So if we don't reset the commands, so yeah, it tells me yeah, I can't do anything with a closed list. I already know that. Um, yeah. Maybe I have to reset the command list. Right after calling execute. I Yeah, maybe I need to do it before. We still have a memory leak. Mm, it could be the GPU memory that is. Nope. Yeah. We're still memory leaking and it's not on the GPU. Neither of the GPUs. Uh, let's see. Perhaps we need to reset the allocator first. Maybe we are actually asking the API to keep on building the allocator. Maybe, yeah, that might be it. Yeah, I actually think that might be it. Hopefully that's it. So when we reset our command allocator, we want to do it before we reset our um, um, command list. I think this is a reset call that only resets the command list. I thought it also took the allocator, but it expects the allocator to be cleared beforehand, I think. Let's see. So what is the error message? Hey, command. Did I disable anything else? Yeah, let's move that back. Maybe it's everything works. Oh my god. Oh my god. Everything works. It's not sluggish. It's not anything. It's not memory leaking. At least from what I can see and I want to see. I imagine that this has like 1000 frames per second or something like that. Um, yeah, great success. All right. Since I wasted about 50 minutes on doing this small change, um, I think I will reboot the stream so that YouTube saves this as a segment. Um, yeah, but I will be back shortly we got done with the update/draw methods, and next we will be doing resources and buffers. Yeah. Funny how things goes. If we, yeah, I'm just gonna test out without doing the waiting if it gets sluggish. Yeah, it does. Or rather, it gets buggy because we try to reset something that is in use. All right. Yeah. All right. Hopefully, I'll be seeing you in the next episode, which I will be continuing on shortly.